I do if they're not mutually exclusive? Well, if they're not mutually exclusive, what happens is I'm overcounting. So what happens is I do the same probability like I did with an OR. I add them, but since I'm overcounting, I have the probability of A plus the probability of B, but some of those B are also an A, so I subtract off both of them. And then you might have to use your independent rules and dependent rules to find A and B. Now, if I look at example 6, according to the algorithm, and I'm going to show you, I don't think we need to use the algorithm on this one, but let's take a look at it. So I want to probably, then I'm going to get a round piece, so I'm going to find the probability that it's round. Well, if I discount here, I got 1, 2, 3, 4, 5 round pieces, don't I? So I got 5, whoops, need my pen there. So we got 5, and then how many pieces are on there? Well, there are 10 pieces on the slide. So I'll get 1/2 then, won't I? Now, let's find the probability that it's orange. Well, on the orange ones, I got 1, 2, 3, 4. So I've got 4 out of 10, or 2/5. Now, what's the probability that it'll be orange and round? Because those are the ones that I double counted. Well, orange and round would be 2 out of 10, wouldn't it? Or 1/5. So to find my probability of getting round or orange, I take 1/2 plus 2/5 minus 1/5. That's according to our rules. Well, I'm going to get a common denominator there to add them. So I'm going to get 5/10. Probably shouldn't have reduced that. So 5/10 plus 4/10 minus 2/10. So that will give me 7/10, or a 0.7 chance of getting picked. Now that's the algorithm. That's kind of the long way, isn't it? Really, if I just wanted round or orange, just don't double count. And so let's do those together. So I get 1, 2, 3, 4, 5, 6, 7. And that's all you got to do. Now, that was kind of a simple one. So they won't always be that simple. So that's why we kind of went through the algorithm on this question.